Hello everyone, good afternoon. My name is Susan James and I'm one of the Outreach Fellows at the School of Mathematics and Statistics, and I'll be your virtual host for today. In this session, we're hoping to give you a bit of an insight into how you can study mathematics and statistics at the University of Melbourne. As many of you would know, the Bachelor of Science degree at Melbourne is very broad, and there are many pathways that you can take in order to obtain that degree. So today, you'll have a short presentation taking you through the basic course structure on how you can study mathematics and statistics in order to reach the Bachelor of Science degree. The presenter today will be Dr Anthony Morphett, and he's one of our tutors from the School of Maths and Stats. After the presentation, I'll introduce you to two more panelists, and then you'll have the opportunity to ask any questions that you want to. So in order to ask those questions, what you'll need to do is type them in at the bottom of your screen using the Q&A button. You can do that at any point during this session. We will see your questions, we'll collate them, and then we'll put them to the panel for you. So we've allocated an hour for this session, well, a maximum of an hour, but it may not take that long. It really depends on how many questions you have after you've seen the presentation. And also at the end of the session, we'll give you an email address for the outreach team so that you can contact us at any time that you want to have some help and advice. So we'll begin now by passing you over to Dr. Anthony Morphett. So Anthony, if you could please put your video on. Thank you.
Hello everyone. I'll just share my screen. Just a moment. Okay. Hi everyone. As Susan said, I'm Anthony Morphett. I'm a lecturer and tutor in the School of Maths and Stats. And in this short presentation, I'll explain to you how to study Maths and Stats at Melbourne University. And if you do choose to study Maths and Stats with us, what will your course look like? Okay. So first of all, options for studying Maths and Stats at Melbourne University. If you want Maths and Stats to be your main focus of your undergraduate course, then the best option is a major in mathematics and statistics. That's part of the Bachelor of Science. So you would enroll in the Bachelor of Science, and then you choose mathematics and statistics as your major. So if you take this option, and if you choose to study Maths and Stats as the major in the Bachelor of Science, you'll typically study mathematics and statistics subjects in each semester of your course, plus some other non-maths science subjects and some breadth subjects. I'll say more about that in a moment. So that's if you want maths to be your main focus. If maths is your main thing and you really want to focus on the maths in your undergraduate degree, well, a major in Maths and Stats as part of the Bachelor of Science is probably a good option for you. But perhaps you want to do lots of maths, but you also want to do lots of something else. Maybe you really love chemistry and you really want to do lots of maths and lots of chemistry. Maybe it's finance. You really want to do lots of finance as well as lots of maths. Well, another option that we have that might be of interest to you is the diploma in mathematical sciences. The diploma in mathematical sciences is it's an add-on degree. It's a concurrent diploma. I'll explain a little what that means in a moment. But it lets you do the equivalent of a mathematics and statistics major alongside another major in one of our bachelor degrees. It's a concurrent diploma, which means that you study it alongside your bachelor degree. So typically each semester you would take maybe one Maths and Stats subject that contributes towards the diploma, and then you'll take other subjects that contribute towards your main degree, whether that's a science degree or commerce degree or whatever case may be. It typically adds some time to your studies, typically adds 6 months to a year, 1 to 2 semesters of extra study time. But at the end, you graduate with a Bachelor of let's say science with a major in chemistry, as well as a diploma in mathematical sciences, which is the equivalent of a mathematics and statistics major. And you can take this diploma in mathematical sciences alongside any of our main undergraduate degrees: science, commerce, design, music, arts, biomedicine. Okay, so what else? Well, maybe maths isn't your main interest. That's okay if it's not. But you want to do some maths to complement your other studies. So maybe finance is your main interest, but you just want to do a little bit of extra maths to complement the finance. Or chemistry, and you want to do a bit of extra maths to complement the chemistry, but you don't want to do the equivalent of an entire major in it. Well, that's where the Melbourne model and breadth and electives come in. You can always choose mathematics and statistics subjects as your elective subjects if you're doing science or biomedicine, or as your breadth if you're doing one of the other degrees. So that allows you to just choose a few maths and stat subjects to complement whatever other discipline you're studying. So I imagine that most of you here today are probably in one of those first two categories. So now let's focus on this middle option, the major in mathematics and statistics. If you go for this option, what will you study? What will your course look like? Well, here is a little picture of what a typical course in the Bachelor of Science, a 3-year course in the Bachelor of Science, will look like. So each row here represents 1 year of the course. So that's year 1, first year. And each box here represents 1 subject. So typically a student would do 8 subjects in their first year, 8 subjects in second year, 8 subjects in third year, and so on. What about the different colours? What do the different colours represent? There we go. Orange boxes represent mathematics and statistics subjects. So of course, this is just an illustrative study plan. I'm not saying that your course would look exactly like this. Everyone's courses are a little bit different, but just take this as a kind of illustrative, typical picture of what a student's course plan would look like. So as you can see, in first year, you take typically 2 maths and stats subjects. You also take some other science subjects. So these might be computing, biology, physics, geology, and you take some breadth subjects. So breadth at Melbourne University means subjects from a different faculty. So these breadth subjects have to be non-science subjects. For instance, they could be a language or history or commerce. There's a whole range of different options for breadth. Okay, so that's first year. And then as you can see, as your course progresses, you gradually do more and more maths. So 2 maths subjects in first year, typically 3 maths subjects in second year, and 4 maths and stats subjects in third year. So those orange subjects, these ones here, these are kind of the core mathematics subjects. These are the ones that you sort of have to do, the essential ones for the mathematics and statistics major. And as I said, the breadth here has to be non-science subjects, so they have to be from another faculty. But the green subjects, these ones that say science electives, they can actually be more maths if you want. With these green ones here, you're welcome to choose additional mathematics and statistics subjects as your electives if you want. Or you can choose some maths and some chemistry, or a bit of chemistry, a bit of physics, a bit of computing, whatever you want for those electives, generally. Okay, so this is kind of the minimum amount of maths that you would do in a mathematics and statistics major. But if you really want to do maths, if maths is your thing and you want to max out, do as much maths as you can, your course could potentially look like this. Okay, if you choose as much maths as you can see you can fit quite a lot of maths into your course. Now, you can't do 100% maths. You have to do, every student at Melbourne University has to do a certain amount of breadth. So minimum 4 breadth subjects across your degree. And in first year, you also have to do some other science subjects. So typically only 2 out of your first year subjects would be 2 or 3 of your first year subjects would be maths, and then your other subjects here are from different science disciplines. So you might do some computing, you might do some chemistry, etc. Okay, so what kind of subjects would you study in these maths and stats subjects here? What kind of things do you study? Well, in first year, your subject options depend on what maths you studied at school and your grades. So we have 4 main pathways for first year maths. I don't want to dwell too much on the details here. All this information is available online and elsewhere if you want to refer back to it. So the main point here is that what maths you study at first year depends on what maths you did at school and your grades. So for instance, if you did intermediate maths only, in Victoria, that's VCE maths methods. If you did intermediate maths, well then you take 3 subjects in first year, subjects called Calculus 1, Calculus 2, and Linear Algebra. If you took advanced maths at school, well then it's like you're already 1 subject ahead. Then you only take 2 maths and stats subjects in first year. We have our standard stream, Calculus 2 and Linear Algebra. They're like our standard first year maths subjects. And we also have an advanced stream and an accelerated stream for students with particularly high marks. So these advanced and accelerated streams are more demanding than the standard streams, more challenging, but more demanding. And so accordingly, you need a stronger maths background. You need a higher score for those to be an appropriate choice for you. Okay. So I've given the requirements here in terms of VCE, the Victorian school system subjects, but there are grade requirements for interstate and international qualifications as well. So for instance, if you've come from New South Wales, HSC, or you've come from done A-levels or something like that, we have equivalents for these requirements in terms of international and interstate qualifications, and we can help you with that individually if you need. So what's the difference between these different pathways? Well, in the end, they all cover the same content. The advanced stream here covers the same content as the standard stream, but it just covers it in a bit more rigor, a bit more mathematical detail. This stream here is recommended for students wanting to go on to maths and stats as their major, if you qualify, of course. But you can certainly still go on to study maths and stats even if you're in one of these earlier pathways here. The accelerated stream, well, actually, that's more aimed at actuarial students. We really encourage science students wanting to do maths and stats to take one of these first 3 streams here, according to your background and grades. Okay. So the point here is that exactly which subjects you take in first year might vary depending on what you did at school, but in the end, though, you end up covering the same material in a way that's most appropriate for you. And by the end of first year, everyone's covered the same material and we're all ready to move on to second year subjects. So what do you cover in second year? Well, there are 4 specializations within the mathematics and statistics major. So from second year onwards, you start to specialize in one of these 4 areas. So first of all, there is applied mathematics. Now, these 4 specializations have been discussed in earlier open day sessions, so I won't spend a lot of time on these. I'll just give a very quick summary. Applied mathematics has a focus on mathematical techniques that are useful for modeling real-world phenomena. So that often means using things like calculus to model things from the real world. So you can see here, for instance, derivatives, differential equations, calculus. Discrete mathematics and operations research. Well, the discrete maths part is the study of discrete structures. So things like networks, graphs, and permutations. This little picture here is a famous problem called the traveling salesman problem, trying to find the shortest path between different points on a map. The operations research part, or OR, part of this specialization is the mathematics to support decision making. So things like optimization and algorithms for decision making. Pure mathematics. Pure mathematics has a focus on understanding abstract mathematical concepts, and it has an emphasis on proof and rigor. And finally, statistics and stochastic processes. Statistics is the tools that measure, control, and reduce uncertainty. help us make sense, help us draw sensible conclusions from noisy data. And stochastic processes is the mathematics that models random processes. So from second year onwards, you start to specialise in one of these specialisations. Each specialisation has its core second year and third year subjects. So going back to our picture here, exactly which subjects you choose in year 2 and in year 3 will depend on which of those 4 specialisations you want to focus on. And if you're doing the mathematics and statistics major, you have to do at least one of those 4 specialisations, but you can do more than one if you want. Okay, so that's the mathematics and statistics major, but what about the other option, the diploma in mathematical sciences? Well, the diploma in mathematical sciences, you can take it alongside most undergraduate degrees and majors. I say most because there's a couple of exceptions. You can't take it alongside other very mathematically intensive majors like mathematical physics, for instance, but the vast majority of our other undergraduate courses and majors, you can take this diploma of mathematical sciences alongside. It has the same first year pathways and specialisations as the maths and stats major. So all of this information on those previous slides applies just as much to the diploma, the first year pathways and the specialisations. In the end, you do the same subjects. You do the same mathematics subjects and maths and stats subjects as someone doing the major. And you apply for the diploma after you've started your degree. So you don't need to apply for the diploma at this stage if you're still in the still at school or still thinking about which courses to apply for. At this stage, you only need to focus on your bachelor degree. You apply for a diploma in mathematical sciences after you've accepted your offer of a bachelor degree at Melbourne University, after you've enrolled and after you've started to choose your subjects. In fact, a lot of people don't enroll in this diploma in mathematical sciences until the end of their first year of study. Okay, that's it from me. Now, time for questions.
Thanks, Anthony, for that very clear presentation. So hopefully everybody out there is a little bit wiser. So what we're going to do now is we're going to bring on 2 more panelists. The first is going to be Dr. Christine Mangelsdorf, who's one of our senior lecturers. And we have Dr. Paul Finch, who's one of our senior tutors and also part of the outreach team. So Christine and Paul, if you could put your videos on and join us on screen. So what we'd like you to do is using your Q&A button down the bottom, basically you can type in whatever questions you would like to have answered. And we do already have one question, so I will put that to the panel now. You spoke about the different VC options, but one of the students is saying, what will I study in first year if I do UMEP, which is the University of Melbourne Extension Programme? So who would like to answer that one?
I can probably take that one, Susan.
Thank you, Anthony.
For those who are watching, UMEP is an extension program that we offer for Victorian students. It lets you do the equivalent of first year mathematics subjects during high school. So our 2 UMEP subjects mirror our 2 standard first year subjects. So there's a UMEP calculus, which mirrors our calculus 2, and there's a UMEP linear algebra, which mirrors our linear algebra subject. So if you've done both of those subjects, if you've completed both the UMEP subjects, then it's like you've already done the standard first year subjects, and you can actually move on to some second year subjects right from semester 1. I won't go into the nitty gritty details here. If that's you, then the UMEP team will be in touch with you at the end of semester, at the end of the year, with some information about those kind of things. So we will provide you with that information closer to the end of semester, at the end of the year, specifically to UMEP students. But in short, you will be able to do some second year subjects right from the beginning if you want to.
Great. So the other one's in a slightly different area. One of the students is asking, what type of subjects can I study as a breadth if I do a Bachelor of Science? So maybe somebody else would like to answer that. Christine, maybe?
Okay, so if you're doing a Bachelor of Science, you can take breadth subjects that are outside science. So they can't be related to the science subjects that are within the Bachelor of Science or the Bachelor of Biomedicine. So you can do things like history, you know, languages, commerce subjects. You might go and do some music subjects, so things that are definitely not related to maths and stats. And there's also some university breadth subjects, which are very broad, and there's a whole suite of these at first, second and third year level. And so some of those are actually offered by our school, things like critical thinking with data, where you can do a little bit of you know, data analysis and things, and analyse some topics and stuff that are going on in the media now. And so you can apply some maths and stats skills, but it's not technically a maths and stats subject. So there's a whole range of these subjects. There's things from learning how to play a guitar through to sports coaching. There'll be something at the university that you can find that you will be interested in to do as your breadth. So the key thing is that it's not in science, and it's not in the Bachelor of Biomedicine, which has a lot of science subjects as well. So on the handbook website, you can actually look for what subjects can I do as breadth for a Bachelor of Science or for another degree, and it will come up with a big long list of everything that's allowed. So you can explore these and have lots and lots of options to do.
There was a question from another student who was actually saying, do I really have to do a breadth? I don't want to write essays, you know, can I do more maths? But as you're saying, there are a lot of options there.
Yeah, I'd add that there is a lot of options. And if you want to pick things that complement what you're doing, you can do that. So while you can't do something like computer science subjects, which you could do as science electives, what you can do is things like the subjects on climate change and sustainability, which look into some of the mathematical modelling behind these sorts of things. There's a subject called logic, language and information, which is about looking at how logic works in mathematics and computer science and in philosophy. And so you've got these subjects which really will help you kind of build that deeper understanding of mathematics and how it's work, or also how statistics and how it's applied around the world. So you can do those sorts of options, and they can be really great options, which are very mathematical, like have lots of mathematical content or will help you do better with your mathematics, but aren't specifically mathematics subjects. Yeah.
Thank you, Paul. So one of the other questions is saying, I can't decide what I want to study at uni yet. When do I need to choose my major? Who would like to answer that one?
Well, I'll answer that one. So you don't have to make a decision until really the end of second year. So at first year, we start with a very general course, and in second year, there's still plenty of space to keep open, say, 2 majors. And I mean 2 distinct majors like mathematics and physics, or mathematics and chemistry. And you can also just start within maths and keep open a few specialisations. So eventually, though, you have to make a decision, and it will have to be by the end of second year so that you know what you're going to study in third year. So the idea is you sort of try 3 things out at first year, then at second year you go down to 2, and at third year, this is where you could either continue on the 2 areas or specialise further. So you've got a little bit of time, at least, you know, 1.5 years to 2 years to decide what you want to major in.
Great. So one student was saying, when you talked about the prerequisites earlier on and the scores that you needed to get in, and they weren't sure whether these were the raw scores or the weighted scores.
Oh, those are, the VCE scores are unscaled raw study scores.
Right. And then on a different subject, somebody was saying, how many hours a week of classes do you have for math subjects?
So I think that depends on whether it's a maths or a statistics subject. So sometimes most subjects will have 4 hours, but some will have 5 hours. Okay, so they all have 3 hours of lectures, and they'll all have a practice class or a tutorial, so a small group class. And then depending on the subject, they might also have a computer lab. So the maths subjects will vary between 4 and 5 hours a week.
Right. So this one's a bit more general. This one says, where can you go from studying maths and stats? And what pathways are available from doing the course? So I think maybe afterwards. So I think this is more about where can maths and stats take you in future? Which is a very broad question. So who would like to have a go at that one? Maybe all of you. Paul, do you want to have a go?
Sure. So I mean, I guess there's a lot of a whole range of possibilities you can have with a degree in mathematics and statistics. So some things you can do, you can do courses, but you can go on and do jobs which actually use the maths and stats directly. So you might go into, you can go and work in finance type situations, or you can go and work with developing computer programs and things like that. A lot of discrete maths and operations research is really useful for those sorts of problem solving things where you've got if you've got a problem that's really hard to solve, and so you want to, instead of finding the best answer, what you're more interested in doing is finding an answer quickly. And so you're okay with finding an answer that's not perfect as long as you can get something quickly. And so those sorts of skills that you learn in that sort of specialization are really handy for all sorts of future careers in things like anything to do with computer analysis and software, so data science and those sorts of things, but also it can be used a lot in like logistics and those sorts of things. So if you wanted to go and work for any company and work with them to kind of help them kind of manage how they move their products around and their supply chains and those sorts of things, that's the sort of thing that a maths thing can lead to if you do operations research. But there's other things you could do if you do more applied maths things. You can go on and do other engineering related. You can go on and naturally leads into lots of engineering sort of things. I guess others might have things to say.
I was going to add that I think the career prospects and jobs that you will get depend on how far you go with your mathematics. So the sorts of job you're going to get is going to be very different if you finish with a Bachelor of Science with a major in maths to if you go on and do a diploma or a master's degree or a PhD. So obviously the more maths training you've got, the more sort of specialist job you can get when you finish. So for instance, you might go into work, if you've got a PhD or a master's in maths, you could go and work in a place like CSIRO and spend all of your time doing very heavy mathematical modelling and directly applying the skills that you are learning in your degree. But if you finish off with just the bachelor degree, or you maybe just go and do a 1-year diploma after it, then you don't have those really in-depth technical skills. So when a company employs you in a graduate program or something like that, they need to do more training on the job, and they really are employing you for what we call your generic skills or your soft skills, your ability to, tackle very difficult problems, your problem-solving skills, your logical thinking, working with other people and understanding what the problem is and then solving it in some way, and then how do you communicate that to a client or to someone else. So those sorts of generic skills are what makes a maths graduate, even from a bachelor degree, very, very employable. And so, but the difference will be in the jobs that you get. As I said, you would need to go into more like a graduate training program there, and they would teach you things about the company or the industry or whatever it is that you are working on. And then you can apply all of those soft skills and learn some more techniques on the job. So there's a lot of different options, but it really depends how far you want to go with your, mathematics, whether you want to finish at the bachelor degree or whether you want to go all through to the PhD. But many options. Maths graduates are highly employable in industry and government. Okay, and of course you can go on to do further study at academia.
Of course, I would point out that they do actually say at the moment that 75% of all jobs in the future are going to require STEM skills. So you're looking at science, technology, engineering and maths. But it's actually impossible to do science, technology and engineering without really good mathematical or statistical skills. So you could kind of rephrase that and say that 75% of all jobs in the future are going to need maths and stats, as part of your skill set. And as everyone else is saying, you can take that skill set and you can apply those mathematical skills across a different range. A lot of mathematics that you would use in medical research is exactly the same as the mathematics that you would use being a quant or a risk analyst in business. So it makes you very, very adaptable, and it makes you very employable for future. Did you want to add something, Anthony? Did I butt in on you then?
Thanks. I was just going to say, following on from Christine. Christine mentioned studying masters, a PhD. So I suppose that's also a pathway. The pathways to further study. So at Melbourne University, we offer a masters it's a master's in science with a specialisation in mathematics and statistics. So that's a natural follow-on from the undergraduate degree. If you've done the undergraduate degree, if you've done the major in mathematics and statistics, or if you've done the diploma in mathematical sciences, well, then you're well placed to go right on into the master's. In fact, we also offer some third-year extension kind of programs where you are able to get a taste of some of the master's subjects in your third year if you're as long as you've got the good marks. So there's a natural progression from the major into the masters in maths and stats if you want to continue on with the maths. But of course, there's also a lot of other different master's programs and other postgraduate programs available as well. For instance, there's a master's in bioinformatics, master's in data science, which are still very quantitative. But some students go on to quite different areas too. Masters in, I don't know, public health or law or all sorts of kind of different things. So certainly there are very good pathways into further mathematics kind of study, but there's also pathways into other fields, anything from education, engineering, law, the whole range.
Thanks. Well, something else that's asked, if you could just maybe clarify the difference between the two different first year pathways, mainly the difference between the advanced and the accelerated streams again. So.
Well, that's probably another one for me. So there's three streams. There's the standard stream, Calculus 2 and Linear Algebra. There's the advanced stream, where the subjects are called Calculus 2 Advanced and Linear Algebra Advanced. And there's the accelerated stream, Accelerated Maths 1 and 2. So the standard stream covers all of this core first year knowledge, all the skills and techniques and concepts that you need to go on to second year. It doesn't necessarily go into a huge amount of theoretical detail. It doesn't go into as much theoretical detail as the advanced subjects. So the advanced subjects cover the same content, cover the same mathematical concepts and so on, but they go into a little bit more theoretical depth about the theory underlying those concepts and how the different branches of mathematics relate to each other and things like that. So there is a bit more of an emphasis on proof in the advanced subjects than in the standard subjects. But in the end, though, you still learn the same techniques. You're still able to solve the same kind of problems, which you need to go on to the second year subjects. The accelerated stream also covers all of that standard first year content, but the accelerated stream actually covers one extra subject as well. The accelerated stream actually covers the content of a second year subject called real analysis. So by taking accelerated maths 1 and 2, you effectively cover 3 standard subjects: the standard calculus 2, the standard linear algebra, and the second year real analysis, which also has a focus on proof. So there is a much higher workload for the accelerated stream because it's basically covering half as much content again. So for instance, you have 4 lectures a week in the accelerated stream rather than 3 in the other subjects. And so much faster pace and much higher workload. Probably not as much of a theoretical focus as the advanced subjects because the focus is more on covering the content fast rather than covering it in depth. And so that's really important for some disciplines like actuarial studies, for instance, where the students really need that extra knowledge right from first year. But we recommend for students wanting to specialise in maths, wanting to major in maths, we recommend the advanced subjects if you have the grades for them.
Fantastic. So one of the questions is, how different is university maths to school maths? And does it just build on the VCE? So Paul, do you want to give this one a go?
So in some respects, it'll be there. Some topics will be familiar to you from high school. So things like calculus and things like that. What's different is that you're going to approach it in a way where instead of just trying to solve a particular problem, what you're going to start thinking about is you can start thinking about, well, which problems can we solve? And if we change the problem slightly, how would that change the answer? And so this kind of leads to kind of a lot more difficult problems in mathematics sometimes, but also kind of some more interesting things where you can understand how things are related to each other and why things work rather than just how to solve a particular problem.
Great. So one says, what sort of science electives are there for selection? And it says, perhaps if you're not strong in science classes like biology and chemistry. So what kind of electives they choose if they're not strong in other sciences? Maybe.
So I'll start off a bit. So you can take computer science. You can take what's called engineering systems design subjects, which is sort of like the introductory engineering subjects, which are more based on a bit of programming as well as working out what it's like to become an engineer. There are things like, geology type areas. There's psychology. There's also areas like history and philosophy of science. So there's actually quite a few options which don't require you to do something like biology, physics or chemistry, where you're going into what I would call a wet lab type situation. You can, do subjects where you don't have those sorts of laboratory classes, but you need to choose something in that area at least at first year. So as I said, computer science, mainly a lot of students will do that, the engineering systems design, and then some of the other areas like psychology, history and philosophy of science, and so on.
Great. So what we have one here that says, how do I apply to do the diploma in mathematical sciences? Maybe.
Yep, sure. You don't need to apply for it until you're already enrolled in your undergraduate degree. So first step is apply for a Bachelor of Science or a Bachelor of Commerce or whatever your preferred degree is. Accept your offer, get enrolled, get your first year subjects sorted out. So with the diploma, some of the subjects can be cross-credited, meaning that some of the math subjects will actually count towards both. That's why the diploma sometimes only extends your course by 6 months, even though it's a full year's worth of study, because up to 4 subjects can count towards both. So typically students you'll do your first year, you'll do the standard first year subjects, calculus 2, linear algebra. And then at the end of the first year, if you're liking the maths, you're happy that you want to go on with it, then you apply most students will apply for the diploma at that stage. And you just apply online through the university's website.
Right. So somebody said, are there any opportunities to try out mathematical research throughout the undergraduate degree? Who would like to have a go at that one?
So I guess there is some chances. So there's a third year research subject where you can do some actual research project. That's part of any science degree. You can do a research project as part of your major. It counts as a math subject if you want. So that's one way of doing it. There's also, we have a vacation scholarship program where students can apply to do a 6-week research project over summer, working with an academic in a particular area. And so that can be a really great way to kind of get an idea of what research is like, and you get to do it kind of full time when you're not doing other things, which kind of can be really a great way of doing it. Otherwise, you'll mainly come across research when if you go on and do a master's, and that's kind of where you get to do a major research project, where you would actually do quite a lot of research over a 2-year period.
Great. So I've got one here that said they're struggling to choose their options at school because there's so many subjects they want to take. Do they have to study specialist maths in order to study maths and statistics later on? So maybe Christine?
So Anthony kind of addressed this in his presentation. The most important subject that you should do is the mathematical methods 3, 4, or equivalent in all the other states. So what we would say is the intermediate maths level. That's the minimum requirement to get into a Bachelor of Science and to get into, therefore, the maths and stats major. The advantage of doing the specialist maths 3, 4 is that you've already done the content of Calculus 1. So you only have to complete 2 first-year maths subjects at the university. But if you can't fit it in, it doesn't matter. You can still do Calculus 1, Calculus 2 and linear algebra and go on to the maths major. It's just that you will have one less elective spot in science compared to someone who did specialist maths. So both pathways are possible.
Great. And in fact, there was another question, and it was actually somebody saying, are the entry requirements for interstate students, where can they find out about them, and are they the same? So maybe Anthony?
I can't give a comprehensive list of every different possibility here, of course, but for the entry requirements for the Bachelor of Science, those are listed on the university website. So if you go to the university's website and the Bachelor of Science course page, they have a pretty good list there of what are the requirements if you're coming from New South Wales or if you're coming from Hong Kong or whatever the case may be. And as for our specific subjects, generally, if you've done advanced maths, as a general rule of thumb, if you've done advanced maths in whether that's in HSC or whether that's in A levels or whatever, then you'll be able to go into the Calculus 2 or the Advanced Calculus 2 streams. Whereas if you've done intermediate maths only, then you'll take the first stream starting with Calculus 1. So I can't really give any more specifics than that. That's best to answer individually. So contact us individually if you want to follow up on that.
Great. And another one said, is it possible to complete a bachelor degree and a concurrent diploma within 3 years instead of it taking 3.5 or 4 years?
Well, that's probably another one for me. Well, is it possible? Only in rare situations. So to do that, you would need to overload and you would need to take lots of subjects in summer semester, for instance. So you'd have to work really, really hard, and it would be a lot of work for you. And to me, I don't think that's really worth it. Like you're better off not rushing things and taking the time to make sure you've learned everything properly rather than trying to pack it all into a short time. So no, it's designed as a 3.5 to 4 years full-time program. So if you're going at the normal study load, it'll take you 3.5 to 4 years. Only if you're really trying to cut corners and overload and things like that, will it go any shorter.
Fantastic. I think that was the final question that we've had sent through. So perhaps it's a good opportunity to let you know that we are actually running 2 more sessions, and I will try and share my screen so you can see when these are. Right, so we have 2 more sessions next week, which have a slightly different focus. The first is on Thursday, and what we're going to be doing there is having a little look more in depth at the different areas, the different research areas that are covered by the School of Maths and Stats. So that session will be broken down, and we'll have academics from each of those areas telling you a little bit about their research area, what's involved in it, where it can go, and then just giving you a few moments to ask some questions. And then on Friday, we're going to be running a 2-hour drop-in Zoom session. So you can come in anytime and you can get some individual help and guidance, advice from various academics in some breakout rooms. So the details of all of those are on our school news page. So you can go on there and the registration links are on there. And lastly, what I really would like to say, if you want to contact us at any time, please go through the outreach email, which is at the bottom. And if it's not something that's for us to answer directly, we'll make sure that your question or your inquiry goes to the right person and you get answered. And we'll then be able to keep you up to date with the things other events that we're running. So I hope that you all have found some useful information today, and thank you very much for joining us. But I think that's possibly the end of the session, and I would like to thank Anthony, Christine and Paul for joining us as well, and hope you all have a good evening. So bye from all of us.